Land Before Time presents. Given the root of a binary tree, return the length of the diameter of the tree. The diameter of the binary tree is the length of the longest path between any two nodes in a tree. This path may or may not pass through the root. The length of the path between two nodes is represented by the number of edges between them. Goal: return the length of the diameter of the tree. This problem is pretty straightforward, so I only have one question. Can the tree be null? No. There must be at least one node in the tree. Alrighty then, let's go ahead and move on to some examples and start brainstorming some ideas. Let's use example 1. If we know that the diameter is the length of the longest path, then we know the longest path can be taken as follows: 4, 2, 1, 3, and 5, 2, 1, 3. If you don't know how to solve for the height of the tree, then I highly recommend solving maximum depth of a binary tree before continuing, as this builds on top of that. Let's start with what we do know, which is calculating the height of the tree. We know from solving maximum depth of a binary tree that we will need to traverse left, then right, and then return the max of left, right, plus 1 on every recursive call. Now, the question is, how do we include this information about the diameter? We know from calculating the height of the tree, the height is returned in the recursive call. So we can't use that for the diameter. Since we are using a programming language like Java, we'll probably need a global variable, and we can call it diameter, which will get updated on every recursive call. We know that in order to find it, we'll have to take the max of the existing diameter and compare it to left plus right. When we return diameter, we should have the correct diameter. Let's walk this through and give it a shot. During each recursive call, we plan to do the following. Height is equal to max left right plus 1. Diameter is equal to max diameter left plus right. I know that explaining trees without being able to draw can be a tad annoying, but we're going to go ahead and do our best. We will start at the root 1 and go left, since the left is not null. Now we are at 2, and we see 2 also has a left, so we go to 4. Now, 4's children are null, so height is 1 and diameter is 0. Now that we're done with 2's left, we see that 2 has a right child, 5, that needs to be explored. 5's children are also null, so height will be 1 and diameter will be 0. Now that we've finished solving for 2's children, we can now solve for 2. Height is 2, and diameter is left plus right. So I'm going to go ahead and clarify the heights are also corresponding to the left and right values. And the diameter is 2. Now we go back up to 1 and see that there is a right child that we need to explore. So we explore 3 and see that there are no children, so height is equal to 1 and diameter is equal to 0. Now we finally can solve for 1, and the height is 3 and the diameter is 3. The output we got matches the output from example 1. With that, let's do a quick runtime and spacetime analysis. The runtime of this is going to be O of n since we have traversed each node once. And spacetime is also going to be O of n, as the height of the tree can be skewed, which will result in n number of elements. Let's collect our thoughts and create a blueprint. Base case: if root is null, return 0. Traverse left, right. Diameter is equal to max of diameter left plus right. Return max left, right, plus 1. Now it's time to ace the interview with your rockstar coding skills. And there we have it, diameter of a binary tree. If you enjoyed the video, show the channel some love. Give it a like or a sub. Don't forget to enjoy a Hot Pocket too. And tune in for the next one.